Okay, so for this one, I want to prove that the derivative of arctangent, instead of arc, I'll just put a little -1 there. That's another way you can write arctangent instead of writing ARC. I want to prove that that is equal to 1 over x squared plus 1. Okay, now this proof is going to start off with the same background stuff as the other one that we did earlier when we did arc sine. So if arctangent of x is gives me some sort of an angle, which it does, then tangent of that same angle gives me the x value. They're inverses of each other, right? And so we come over here and we think of this as a triangle once again, where my angle is here. Now tangent is opposite over hypotenuse. So tangent is opposite over hypotenuse, so I need this to be a fraction. This is my opposite. I'm sorry, I'm saying that wrong. Tangent is opposite over adjacent. Okay, so if tangent of theta is x over 1, then this is my opposite and this is my adjacent, and I just need to figure out what is my hypotenuse. So using, just like in the last slide, we're going to use Pythagorean's theorem to do that. X squared plus 1 squared is equal to h squared. Okay, so we have x squared plus 1 equals h squared. Taking the square root on both sides to solve for h, we get the following: the square root of x squared plus 1. So the hypotenuse, which we will need later in this problem, is the square root of x squared plus 1. Okay, so now we're ready to go ahead and begin our proof. Off we go. So tangent of arctangent of x, we know by the property of inverse functions, is just going to equal the x, because the tan and arctan cancel each other out. I'm going to take the derivative on both sides, just like last time. On the right side, just equals 1, and on the left side, we have a chain rule. The derivative of the outside multiplied by the derivative of the inside. The derivative of the outside, the derivative tangent, as we've already proven earlier, is secant squared. And we're not going to change the inside for that. But we are going to multiply it by the derivative of the inside, which is the piece I'm trying to find the derivative of. So since this is what I want, I'm going to divide both sides by this expression here. And I end up with the following. Oops. This is now all by itself, which is precisely what I'm trying to find. What is the derivative of arctangent? And now it's 1 over secant squared of arctangent. Now, just like on the last slide, arctangent is equal to some angle theta. Secant theta, we have to go back up to our triangle to figure out what that is. Secant, in case you don't remember, is hypotenuse over adjacent. So we figured out our hypotenuse was this. This is my adjacent, so it's going to be the square root of x squared plus 1 over 1. So I'm going to replace secant with the square root of x squared plus 1. But notice it's secant squared. So since it's secant squared, whatever secant equals is going to be squared. Secant was equal to x squared plus 1. Now if you square a square root, the square and the root just cancel each other out. And we are left with the fact that the derivative of arctangent is 1 over x squared plus 1. And there's that proof. And I'll do one more. We're going to talk about the derivative of arcsecant, and that's it.